Okay, welcome back. This is the second part of the video, the second video for the solution for the second part of the worksheet, worksheet number 1. Okay, so this problem here is asking you to calculate the electric field due to a line that has a uniform charge distribution Q, which is equal to lambda L, and lambda being the charge per unit, the charge per unit length. Now, according to the electric field is equal to 1 over 4 pi epsilon, and then the integration of this is dq over r squared, and then I have to find the direction using the vector r hat. And dq is equal to lambda dx, and x is the distance that goes from x goes from 0 to L. That's the limit of the integration. So my problem is in this guy here, r hat. And if you look, this is my electric field, which if I place a positive test charge here, that means the electric field will be this way. That means it has two components. It has the EX component and the EY component, and I have to find each one of them. EX will be E cosine the angle theta, and EY will be equal to E sine the angle theta, and theta is this angle here. Okay, so cosine theta will be x over r, which is the square root of y square plus x square, and cosine theta will be x over that. Okay? So I have two equations, or at least two integrals that I have to solve. Well, the first one is 1 over 4 pi epsilon. Let me change the black color just so that 1 over 4 pi epsilon, and then 0 to L lambda dx over x square plus y square, right? And then multiplied by cosine, this is x, so cosine theta, and then I have of course I already have dx. And cosine theta, as I said, is simply equal to x over square root of x squared plus y squared. EY will be equal to 1 over 4 pi epsilon 0 L lambda dx again, x squared plus y squared again, and then instead I have to multiply by sine theta, and sine theta will be equal to y over square root of x squared plus y squared, and then you have to do the integral, both integrals, and then you have the electric field will be equal to Ex I hat plus Ey j hat. Yeah, that's the and Ex is this guy, and Ey is this way, and we know that the j hat is positive, right? And this guy will be negative because it's pointing in that direction. Okay, that's the solution, or at least some hints or some points about the solution of problem number 3. Okay, problem number 4, very quickly. Problem number 4 says that you have a dipole, okay, and this dipole is like this. Okay, the distance, so I have one of them is minus q and one of them is plus q, and the distance between them is given, so this distance here is given, d whatever it's equal to, and the distance is equal to that much, and the charge is given. Sorry, I gave you the dipole moment P, I gave you that, and he also gave you the electric field E, gave you the electric field, and he gave you the direction of it. First of all, draw this. So this is drawing the electric field is along the x, positive x, uniform and externally uniform electric field of magnitude. So the electric field is this way. That's my electric field. And then he wants you to calculate the amount of the charge. P is equal to dq, so you can calculate the charge from there. And then the last thing, calculate the magnitude of the torque. You know, you have the definition of the torque, and you can calculate that directly from what we've taken in class. It's a very straightforward problem, in fact. Okay? The last problem is the one that we need. Problem number 7 is the one that we need to go over at least in a little bit of detail. So I have a parallel plate capacitor that is like this, and I have the negative plate at the bottom and the positive plate at the top, and then I have an electron that enters here. So this is an electron, and then because as we discussed this very in great detail in class, then this is what it's going to do. That's the path it's going to do, and then the electric field, as we know, the electric field is this way. It's uniform inside the parallel plate capacitor, and it will be this way. So this is the electric field. Okay. Now the question he wants you to find is that find the magnitude and the direction of the electric field. So he wants to find the magnitude and the direction of the electric field. Now remember, you have a uniform electric field. The way he wants you to do this is using kinematics. And as you can see here, this is basically a projectile motion, a particle, a charged particle that has a mass, an electron has a mass, and it's moving in a projectile motion that can be described in x, let's say x direction or x motion, and then the y, or the motion along the y-axis. Okay, the motion along the x, I have v0x. He gave me that the initial velocity, which I think is equal to 7 times 10 to the power of 6 meters per second, and v0y is equal to 0. And he told me that x is equal to 2 centimeters, which I have to convert to meters, and y is equal to 0.15 meter. So what can I do from here? I know that v, right, x, which is constant, is equal to v0x, right? That's constant. So that means x is equal to v0 times t, or vx or v0x times t. So from here I can find t, which is simply x over v0x. I found the time taken the electron to go from here to there. I can use that in the y motion, where I have y is equal to v0y plus a half at squared. v0y is 0, right? Just so that here. So then that means y, which is this side, is 0.15, right, is equal to a half a, and t, the one I got here, t squared. So from here, what do I get? I get the acceleration. Okay, so I got the acceleration from this one. Now once I got the acceleration, I can go back and I say F is equal to m times a. M is the mass of the electron, and a is this acceleration, ay. So that means the force along the y direction, right, along the y direction is equal to is m, the electron times ay. M, the electron, is known, and ay I just calculated. And from here I know that the electrostatic field will be equal to what? E will be F divided by Q naught, and this case is equal to Fy divided by the mass of the the charge of the electron, which is known, and I can find the electric field. The direction I know it's down, it must be down, and its magnitude is that. And this is the solution for the problem, and this is the solution for the whole worksheet. So hopefully this, you have remember, you have to work out all the details. I just gave you the hints and points here and there, and you have to work out all the details, especially the mathematical details. Any details that, the calculations, arithmetics, algebra, science, and all of this. And be aware, I reviewed the first video, and I found that I made a mistake in the first problem, where I took the tension to be m sine theta. I took the sine theta, t sine theta, which is supposed to be t cosine theta. So make sure you pay attention to these little mistakes, which I just, sometimes I just don't pay attention to them. Okay, and remember, the purpose of these videos is to provide some hints and some head starts for you to do the worksheet. Okay, and hopefully you'll find them helpful, and I'll see you in the next set of videos for worksheet number 2. Thank you. Good luck.